Hello, distinguished viewers all over the world. Welcome to Simplified Math class once again. I am your host, Mr. Mike Omini. Please, if you have not subscribed to our channel, don't forget to click the red subscribe and the bell notification. God bless you as you do that. All right, in our last slide, we treated angles of elevation. All right, and so today we'll be taking the angles of depression. There are two concepts that are used, most at times the same time. Why? Because in most cases, the angle of elevation is always equal to the angle of depression by alternate angle. I will show you that later. All right, so we have a question on the board here. They say the boy standing on the top of a cliff, which is 250 meters above sea level, observes that the angle of depression of a car on the ground is 40 degrees. How far is the car away from the foot of the cliff to the nearest meter? All right, so we want to get the distance between the car and the foot of the cliff. All right, so please watch this. There are two ways we are going to do this. The first way, the first method, method one. Watch, we are going to have this. So this is a boy. Now the boy is here on top of this cliff. That's where the boy is. The boy is on top of the cliff. Now this is the horizontal eye level of the boy. That's the normal high level of that boy. And then he observes something here. Okay. So the boy observes a car here, and the angle of depression, which is measured from this eye level, the horizontal eye level, to where the car is. So this is the angle of depression. This is the angle we are talking about, and that angle is 40 degrees. So if one on top of a cliff suddenly changes his eye level and looks down, so he has just moved from the normal high level to what he just saw on the ground level. So that's the angle of depression. But understand that the angle of depression here, 40 degrees, is also the angle of elevation here, 40 degrees, by alternate angle. That's what I was trying to say. So that angle is also the same angle here, 40 degrees, by alternate angle. Yes, this angle is equal to this. So, and if you observe this, you see that this is the angle of elevation of the top of this cliff where this boy is, the angle of elevation of the boy from the car. It means that the car here will observe this boy on top of the cliff at an angle of elevation of 40 degrees. Whereas the boy himself will observe this car from the top of the cliff at an angle of depression of 40 degrees. All right? So it therefore means that whoever is in this car, for him to aim at this guy and shoot, he can get him at 40 degrees. Whereas the same person here, on top of the cliff here, can aim at somebody in the car and shoot at 40 degrees. So the angle of elevation here is equals to the angle of depression, which is by alternate angles. All right, so that is that. We are going to solve that by two methods. First, by using the alternate angle. So this is the first method, method one, by the use of the alternate angle. All right. Okay, so we have that a boy standing on the top of a cliff, which is 250 meters above sea level. All right, so let's call this point point A. Now, from the point where the boy is to the ground level, we have 250 meters. If I don't want to call it A, I can call it ground level G. All right, so from where the boy is to the ground level, it is 250 meters. Now, they want us to find how far is the car away from the foot of the cliff. How far is the car away from the foot of the cliff? All right, so I can also call here F if I want to. That's the foot of the cliff. So we want to know how far is the car away from the foot of the cliff. The boy is on top of the cliff. The boy here is on top of the cliff. This is the foot of the cliff. All right, so we want to calculate this point here. Let's call it X. That's what they want us to find. All right, so since this angle is equal to this angle, now we can find here by the use of SOHCAHTOA. So we have SOHCAHTOA. Why are we using SOHCAHTOA? Because we are still dealing with a right angle triangle. All right, so we want to see the trig functional identity that, that tells us the relationship between the opposite 250 and the adjacent, which is x. I've already told you before now that here is the hypotenuse, and where the angle is the opposite is this side, and then here is the adjacent. So the only trig functional identity that relates opposite to adjacent is tan, TOA. So we have the tan angle of theta is equals to opposite all over adjacent, which means that the tan angle of the theta is 40 degrees, will be equals to opposite is 250 all over adjacent, which is x, which is what we are looking for. So we'll make this over 1, all right? X will multiply this, so we are going to have x tan 40 degrees is equals to 1 will times 250 to give us 250. Therefore, x alone will be equals to 250 divided by tan 40 degrees. Tan 40 degrees. So we are going to have 250 divided by the tan angle of 40 degrees. The tan angle of 40 degrees will give us 0.8390. 0.8390. Therefore, our x, which is the distance between the foot of the cliff and the car. All right, so we are going to divide 250 divided by 0.8390, and we are going to have 297.9 meters. To the nearest meter will be 298, all right, meters to the nearest meter. All right, so we've been able to calculate the distance between the car and the foot of that cliff as 298 meters, which is our option A. 298 meters. It's that simple. So this is method 1. The method 1 is by the use of what we call the alternate angle, understanding that angle of depression is always the same thing as angle of elevation about a fixed point. So it means that if I'm on the ground, the same angle I'll use to observe an object up there is the same angle that the object up there will observe me on the ground. But I am looking at that object at an angle of elevation, while the object is looking at me at an angle of depression. And that angle of depression and the angle of elevation will be equal by what we call alternate angle. So we have applied that to solve for what we want to solve. So that's method 1. All right, so let's try it using method 2 to see if we'll still have the same answer. All right, so I'm going to try that using method 2. But in the method 2, I will not consider the alternate angle. All right, I will just leave it this way. So after having what you have, which is this, all I need to do is understand that from this point to this point is 90 degrees. That's a box, that's 90 degrees. And so if here is 40 degrees, what will I add to 40 to make 90? So it means here will definitely be 50 degrees. Please understand that. So here will be 50 degrees, all right, which is angle on a right angle. All right, so understand that this is a right angle. From the horizontal level to here is a right angle. And so since the angle of depression here is 40 degrees, the leftover here will be 50 degrees. Because 40 plus 50 will give us 90 degrees. Please take note of that. So the angle at B here, the angle at B will be equals to 90 degrees minus the 40 degrees that has been given. Or let's say minus theta, which is 90 degrees minus the theta is 40 degrees. And that gives the angle at B to be 50 degrees. So we'll put the 50 degrees here. So which means we are no more interested with any other angle apart from this angle 50 degrees. And since we are trying to relate here and here, we've been given here and we want to calculate here, this is still opposite all over adjacent because this is the longest side, which is hypotenuse. So this side now becomes the opposite, while this side becomes the adjacent. So opposite and adjacent, we are still using tan. We are not using 40 degrees again. So the angle of theta will be equals to opposite all over adjacent. So which gives us the tan angle of the theta now is a 50 degrees. All right, will be equals to opposite. The opposite to this place is x. All over the adjacent is the 250. So we can make this over 1. X times 1 will give us x is equals to 250 times tan 50, you're going to have 250 tan 50 degrees. So our x will be equal to 250 multiplied by what is tan 50 degrees. All right, so let's check that out. The tan angle of 50 degrees will give us 1.1918. 1.1918. And so we are going to multiply 250 by tan that. So we want to multiply 250 by 1.1918. And of course, we are going to have 297.9, which of course will be equals to 298 meters to the nearest meter. So you can see that irrespective of the method we use, we still have 298 as our answer. So whether we decide to use the alternate angle of 40 degrees to work with 40 degrees, or we decide to use the angle about a right angle, all right, where we have the right angle and we decide to use the angle here, okay, which we call the complementary angle. A complementary angle to 40 degrees is 50 degrees. All right, two angles are said to be complementary if the sum of the two angles gives 90 degrees. So the complementary of 40 is 90. So if we decide to use the complementary angle, which is 50, and still work, we'll still have the same answer. So irrespective of the method you use, you can still calculate the angle of depression. It is that simple. All right, so let's try a second example. All right, a second example using the angle of depression. Let's say, for instance, we were told that number 2, a man on top of a mountain observes that the angle of depression of an object on the ground 75 meters away from the foot of the mountain is let's say 25 degrees. Find the height of the mountain. All right, so here we want to find the height of the mountain based on this information we've been so given. All right, so let's see how we can try that using any of the two methods. Let's see how we can do that using any of the two methods. All right, okay, so we have that a man is here on top of the mountain. So this is where the man is, and he observes that the angle of depression of an object on the ground. So he wants to observe the angle of depression of an object here. The object is here on the ground of an object. The angle of depression is 25 degrees. So here is 25 degrees. That's what is given. And if that is 25 degrees, you should understand that the alternate or the complementary angle here will be M. Angle at M will be equals to 90 minus theta. So the angle at M there will be 90 minus 25 degrees. All right, so that gives the angle at M is equal to 90 minus 25 degrees will give us 65 degrees. All right, so which means here now will be 65 degrees. So we want to use the complementary angle. But if you want to still use 25 here to work, you will still have the same answer as what I will have here. So whichever one you want to use is either you subtract that to get this angle. You subtract this from 90, 25 from 90 to get this angle at 65, or you ignore that angle and use the alternate angle. Since here is 25, here of course will still be 25. So any of the two will give you the same answer. All right, so we now have that if the distance, they say the man on top of a mountain observes that the angle of depression of an object on the ground, this is the object, 75 meters away, which means from here to here is 75 meters. Now they simply want us to find the height of the mountain. So from the mountain to the ground level, we want to find h, which is the height of the mountain. All right, so we still apply SOHCAHTOA. We still apply SOHCAHTOA and observe that already this is 65, this is the opposite to the angle, and this is adjacent. So we are still using tan. In most cases, when we have angles of elevation and depression, tan is the most widely used trig functional identity in solving angles of elevation and depression. Take note. But that doesn't mean that the equation cannot be coined for you to use maybe ka or so. It can be, but in most cases, it's always TOA. All right, so the tan angle of theta is opposite all over adjacent. So the tan angle of the angle we have here is 65 degrees. Is equals to opposite is the 75. All over adjacent is the height of that mountain. And we want to find the height of the mountain. So we make this over 1 and cross multiply. H times this will give us H. The tan angle of 65 degrees is equals to 1 times 75 will give us 75. Therefore, H now will be equals to 75. We divide it by tan 65. Because we are trying to make H the subject of formula. So whatever is here will come down here. So that's what we have here. So we are going to have our H to be equals to 75 divided by tan 65. So the tan angle of 65 degrees will give us 2.1445. 2.1445. Alright, so we want to divide 75 now divided by 2.1445. And that will give us the height of that mountain. Therefore, the height of the mountain will give us 34.97 meters. And of course, it depends on what they say you can approximate, But in the question, they didn't tell us to approximate, so we leave our answer as 34.97 meters. So that's the height of the mountain. So even if you decide to use this angle to be alternate, that's 25, and use the 25 to work with this and this, you will still have 34.97 meters as the height of that mountain. So this is angle of depression, you know, one dimensional, where you have only one angle. But when we meet next in angle of depression part 2, we'll be solving the two-dimensional problem where you're giving two angles of depression. Let's say, for instance, a man on top of a mountain observes two cars, C and A, on the ground at angles of depression of 30 and 60 degrees. And you are asked to find maybe the distance between the two cars. You can be able to do that. You know, that's the worst scenarios to say when it has to do with angles of depression. But it's quite easy to handle. As far as I have shown you what to do, you'll be able to do it very well. All right, so please thank you for watching our slide today, angles of depression. If you enjoyed our class, please give us a thumbnail. If you have any question whatsoever, drop it on the comment section. I will respond to your question. If you enjoyed the class, you can also comment how nice the class is. And please don't forget, click on the red subscribe and on the bell notification so that as we produce more of our videos on mathematics, you can have them as pop-up messages on your phone to watch them on real time. And as you do, of course, you'll be the great mathematician that we want you to be. See you in the next slide, and God bless you. Cheers.